Hello, today I am presenting my Module 3. Module 3 covers the general linear model, which consists of MRC and ANOVA. Here I have displayed the equation for the general linear model, where y is the dependent variable, b sub o is the intercept, x is going to be multiple variables, b is going to be the weight of the predictors, and e is going to be our residual. This is going to be the basis for the two types going forward, MRC and ANOVA. Here I have Here's the data I'm going to be using for Module 3. You see we have 4 dependent variables, the y variables, and then we have 7 covariates, which are going to be the x variables, and then 8 factors. They are cut off at the bottom, but that's as much as I could get onto the screen. Something that is important to note is that even if we have complicated statistics, when we are performing regression analysis in the GLM, we need to be able to translate the results we are getting so that non-statisticians can interpret them and understand what we are trying to show. King. Here's the data. Here I've hand calculated a bivariate regression using X and Y. I got our variances and then I was able to calculate the covariance and come up with the regression equation y equals 0.06x plus 5.47 plus e. Before moving on to the analyses I have on the screen, the purpose of MRC is to quantify the relationship between several predictor variables and a dependent variable. The assumptions of regression are that the relationship between x and y is linear, the predictor is sensible for the outcome, the prediction of y does not require other predictors than x, there is no measurement error, residual equals 0, there is homoscedasticity, which means the variance is constant for all values of x, errors are random and y correlated. Predictor uncorrelated with error term, and errors are normally distributed, which I will show as the slides progress in more detail. Before moving on to the analyses I completed using our software, it is important to note that as a researcher, we must be cautious in how we choose our statistical methods in interpreting the results. Cortina. I used y1 as my dependent variable and x1 and x2 as predictors. You can see the intercept x1, x2, and the interaction between the predictors x1 and x2 in this table. x1 we can see is the only p-value of 0.004 and a 0.01 significance level, so we can reject the null for x1, while the rest of the variables have too high of a p-value. Before moving on, looking at our VIF concerning the MRC, we see that the x1 and x2 covariates are above 1 but on the lower end of 1, so we don't have too much concern for multicollinearity here, but we should still do something to ensure that we do not. Here I'm using the series plots to see rectilinearity between x1 and x2 and our dependent variable. We would ideally like to see the purple and blue lines in line with each other and an even blue line. We see here that x1 is much more along the lines of what we are looking for, while x2 has a strong downward curve. Looking at more diagnostics of MRC, in the top left plot we are looking for independence of residuals, and we want to see a horizontal line with the red line being right around it, which comparatively it seems we are pretty close to here. Next, in the bottom left, we have the QQ norm plot, and this seems to be a pretty normal distribution minus the tails where there is some deviations, mainly on the left. Then in the top right, we look for heteroskedasticity, and we see there are some evidence it could be there, but it shouldn't be too much concern that we have for it. In the final plot, we are looking for outliers, and we see a few in 14, 20, and 22. We also see the parameter estimates here with Cook's distance. It would probably be a good idea to see what the observations would look like without these outliers, but it shouldn't be of too much concern. We have some significant results when it came to covariate X1, but not in the remaining results. We could possibly add more predictors for this and explain the dependent variable better, but let's move forward to ANOVA. The purpose of ANOVA is to test the degree to which two or more groups vary or differ. There are 4 primary assumptions in ANOVA. The responses for each factor level have a normal population distribution. These distributions have the same variance and the data are independent. And the factor effects are linear. Looking at more diagnostics, we have some significant results when it came to covariate X1. Moving on to ANOVA, I'm still using the dependent variable of y1, but now I'm comparing it with factors f1 and f2. We see here that I have another significant finding with f2. It has a 0.03 p-value, while f1 and the interaction between f1 and f2 do not have significant findings. We see our sum of squares and mean of squares, which is showing our variances for ANOVA. Moving on. Looking at the diagnostics for ANOVA, we see that in the top right plot, using the QQ norm plot, the values seem to be normally distributed. At the top right, the 30 is giving us a little difficulty, but other than that, it looks pretty good. In the bottom right plot, we can see the red line is pretty even with the dotted line, so the residuals are pretty independent. In the bottom left, we see there shouldn't be too much concern for heteroskedasticity. And in the final plot, we see some outliers, but they don't seem to be too impactful. All in all, I would say that we should probably choose the MRC model because of the unbalanced design in ANOVA, but they both had one significant predictor, but non-significant results as a whole. There are several similarities and differences between ANOVA and MRC. The similarities are that they both have similar assumptions underlying their models, they offer similar hypothesis tests, require linear data, and their focus is on understanding variance. There are differences in the two parts of the GLM and the way they approach the data. The easiest way to distinguish them is ANOVA is error in observations and MRC is error in model. They also require different levels of data. ANOVA uses factors while MRC uses covariates. They focus on different diagnostics, residuals being the primary focus in MRC. The variance in them is on different levels as well. MRC is on individuals while ANOVA is on groups. And that is going to complete my Module 3.